Our two goals for today and this lesson here, we're going to find the measures of central angles and something called arcs. We're also going to find the circumference and arc length. So our first skill that we want to do is to know the vocabulary surrounding circles. Surrounding circles? Yeah. Okay, stupid. All right, so radius. What is a radius? Now, we already know what a radius, I'm sure, is, but radius, of course, has to start from the center and goes all the way to the circle. Now, I just want to give you the heads up about what the circle is. The circle is not where I am now drawing. This is not the circle. The circle is inside, not inside. The circle is just the black piece. That is the circle. So don't think of it as a disc or a frisbee that you throw. The frisbee is circular, but only in the sense that its outer rim forms a circle, not because of the stuff inside, okay? So when I say to the circle, I mean to the black line that represents the circumference. So this is the circle right here. All right, so the radius goes from the center to the circle. Center to the circle. Now, some people might say edge of the circle, just to clarify, but to the circle pretty much. Okay, and we usually denote this with the letter R. Next, we have a diameter, and a diameter is edge to edge. So this whole thing is called the diameter, and it usually is represented by the letter lowercase d. How many R's make a D? Two R's make one D. So the diameter is goes through the center. It goes through the center, edge to edge. So therefore, because of that, D is 2R. 2 radii is the plural for radius, radii. 2 radii make one diameter. Next is what's called a central angle. A central angle is any angle made by 2 radii. Made by 2 radii. Now we do want to put letters down so we can start naming these as well. So let's just take, for example, this here. If the center is, and the center normally is, oftentimes just called the letter C there. I also want to have some endpoints of the angle. So for our sake, we'll say M and T. Okay? So the central angle here, in this instance, is angle MCT. Angle MCT. And we'll unpack that in just a little bit. Now, a minor arc, let's define what arc is first. An arc is a piece of the circle. An arc is a piece of the circle. So in this case, we can subdivide the arcs into 3 categories. We have minor, major, and semicircle. So first off, a minor arc is any arc that measures between is between 0 and 180, not including. Now I'll unpack this right here, what I mean by this, the measure of the arc. This right here we'll unpack that in just a minute. So very similar to acute angles, right? Acute angles is between 0 and 90, non-inclusive. And so in the same way, we have a minor arc. All right, next is a major arc, and this is going to be 180 degrees. the measure of the arc has got to be between 180 and 360. And lastly, the circle, it's a semicircle, the measure of the arc is exactly equal to 180. Hence the word semi, which in this case we can say means half. Naming arcs. Minor arcs, just to give you a heads up, minor arcs need 2 letters. We need 2 letters. Major arcs need 3 letters. And so do semicircles. Need 3 letters. All right, so minor arcs are arcs that are less than 180 degrees, so less than half the circle. So let's look here. Here's a minor arc right there. Arc RS. So there's one of them. So this is how we write it. RS, but we have a little arc, like a rainbow that goes above it. Next, we have another minor arc here, QR. QR is another one. Now, of course, you might ask, well, Swenson, what if I started at S and I said SR? Well, that's fine too. You could say arc SR. Here I'm just going alphabetical, but if you start here and go this way, you could also call it arc SR. What other minor arcs do I have here? I've got this one here, QU, arc QU. I have another one here, arc UT. Another one, arc TS. I'm actually not done though. But Swenson, we got all the way around. We're not quite done. What other minor arcs are labeled here that have that aren't just consecutive points like that? So other options here, I could go from Q to S, and that would still be minor. So we have to think about overlapping as well. Not just QS, but I could have gone U to R, U to R there. As well. So QT is another one, arc QT. And let's see, we've done this, we've done all the individual ones. We've done this overlap, we've done this overlap, we've done this overlap. Notice that UTS is not going to be minor because it looks like this is a diameter. So therefore it looks like this goes halfway around. So it looks like we're good to go on that. So let's continue. We're going to name the major arcs. So R, if I start at R and I go all the way around to T, that's halfway. In fact, maybe doing the semicircles might be a little bit faster. So RS to T is a semicircle. So let's just do that one here. RST, arc RST. Next, I could have gone the other direction. Remember, RST requires me to go clockwise. But what if I wanted to go the other direction, which would be the other arc? RQT. So arc RQT. Just to give you a heads up. So the question, of course, rises, what if I said RQT? Or what if I said RUT? Well, notice that I'm essentially ending in the same spot and going in the same direction. So no matter what, if I call it RQT or RUT, it's the same one, just different names. Just like I can rename RST to be TSR. I'm just going in a different direction, starting in a different location. So this one has at least two names, besides going backwards of those. All right, other semicircles? Well, I can start at S, STU. STU with an arc. And next, going in the other direction, SQU. That one would work. Again, remember that SRU is equivalent. So now what we have to look at is anything that goes bigger than the semicircle. Bigger than a radius here. So we've got a couple options here. If I start at S, go through these points here and end at T. I start here, go through these points and end at T. So SRT would work. SRT will work. Now notice I can't go past T without looping. S, T ends up back here, so I can't call that a major arc. So let me start at R and see what I get. I can go R through Q all the way to S. R, Q, S works. So another option here, starting at Q, go all the way to R. So Q, U, R. Notice I didn't have to go all the way to R. I could have stopped at S. So Q, U, S. Q, U, S would have also given me, and notice that neither of these have Q and S to begin with, begin and end. So Q, U, S also works there. All right, so now we've got to determine these, and we get those. All right, so the key to arc measure, so we can measure angles, but we can also measure the arc. And the key on this one is that we need to know the central angle. We need to know the central angle because that's actually where it comes from. Whatever the central angle is, the arc that gets intercepted, and intercepted means like eaten up, like Doritos. So it's going to look fairly straightforward. So look at this, take a gander here. The central angle here of angle URT is 114. Hence, thus, and therefore, this arc right here, the measure of arc UT, is also 114. So all we do is, whatever the central angle is, that's the arc that's being intercepted. That's its same measure. So, in this case, this is how we would write it. The measure of arc UT is 114 degrees. So now let's look again at this one. The measure of arc UVT. So here's U, here's V, and here's T. So this one you say, wait a tick. How can I know the measure of all around here if I don't know the measures of the pieces? And what's that? Well, get this. What's the measure all the way around? 360. And notice, we're just not including that. So the measure of UVT, of arc UVT, is actually 360 degrees. Subtract the 114. So think of it like supplementary-ish, or completing the circle. Also might think of complementary, could be the word as well. 246 degrees, because it's the leftover part from this minor. All right, what about this? Part C, the measure of arc UTS. Here's U, here's T, and here's S. Good, and why would you say that? So since this is a since this is a diameter, UTS has to be all the way around, halfway around. So in this case, we're going to get 180 degrees because it's a semicircle. So now that brings us to this part here. What's the measure of VUT? VUT. Whoa, how big is that right there? Because of the right angle, we know that this right here is 90 degrees, so is the measure of the arc. And so, just like in the olden days, when we took a segment and we had another segment next to it in a straight line like that, then the measure of the whole thing was 7. That's called the segment addition postulate. Exactly the same thing, but instead of having straight segments, we have curved segments. So there is a postulate that simply says that if you add adjacent arcs together, it's just the same as going all the way around like that. So in this case, we're taking the 90 plus the 114 to get 204 degrees. So as we look at the next problems here, what I like to do, even before I look at all the individual, clearly I have a lot of measures to find on this one. I find it's a lot easier to actually go ahead and start filling in the blanks over here, which therefore means I'm filling in the blanks up there. So then I can just start doing my adding and subtracting from stuff I already know. Well, clearly NR is a diameter, which means this is a semicircle, which means if I say 82 plus the 63, whatever's left over is going to be the PQ. So this one has to be 35 degrees here. Now here's another thing. What do we know about this angle right here? ROQ related to MON. What's true about these two angles? Starts with a V. Vertical angles. I know, it's been so long since, remember vertical angles are congruent. That was like first quarter love, man. That was so long ago. And now these two here have to be supplementary. So this is slightly less than 120, so 117 right there. Now, you could probably fill in the gaps a lot easier with that.